Okay, so welcome back. This is IB. So it's like the 2023 IB AAHL November. Okay, November. Section B question. So this one just for time issue. This solution is already in my SO question paper, so we can go through that at your spare time. So I think this is relatively easy, so I just skip this one. So let's directly try 11. So how many questions do we got? We got 2. Okay. So we have a level 7 question at the end. I think this complex number and the Morse theorem and some trigonometry as well. Okay. And this one will be, I think, Maclaurin series, right? So I just add a page from here. Okay. So let's see. So we have an fx here. So find the coordinates of the point of the curve where the gradient is 0. And they given you that as well. So I think, so part A, so I gave you this, right? So E cosine 2x. So we just need to differentiate this like normally. So according to chain rule, so first differentiate it outside, which is E itself, and then differentiate it inside, which is negative sign, and then differentiate inside again, which is 2. So chain rule upon a chain rule. And then we just equate this to 0 because we want to find the gradient is 0, right? So 5 marks, and then we have the domain here. Okay, so let's see here. So divide both sides by 2, this is gone. Divide both sides by a negative, this is gone. And then just here, just use some common sense. An integer, or a number, sorry, a positive number, power to everything is still a number, so it cannot be 0. The only thing that here could be 0 is sine 2x. So we just solve for this. Okay, and we know x is between negative power 4 and 5 power 4. Okay, so then 2x would be between negative power 2 and 5 pi over 2. Okay, so remember to expand the domain in case you need the answer. So I'll just let this theta here. Okay, so sine theta equals 0. So the negative part will be negative pi, but negative pi will be out of the range. So we just take the positive part. So theta could be 0, pi, or 2 pi. Okay. And can we have 3 pi? The answer is no, because this is like 2.5 pi. Okay, so we have 3 answers here. So, and then just solve for x. So theta will be 2x in here. So 0 pi, 2 pi. Divide everything by 2, then you got 0, pi over 2, and pi. Okay, so that's the x coordinate of that. And then we need to find the, we need to find coordinates, right? So we need to plug it in. So let's see, just right here, f of 0 would be e to the power of cosine 0, right? So cosine 0 is 1. Okay, so that's basically it. And then f of pi, it's e to the power of 2 pi. So cosine 2 pi, my bad, should be power 2 here. Cosine pi would be negative 1, right? Negative 1, I think so. Cosine pi, just to make sure, yeah. And then the final one will be f of pi, okay, because this is pi. So plug it in, then you have e to the power of cosine 2 pi, which is 1. Okay, which is 1. Do we have any 0 there? So cosine pi, just to make sure. Cosine 2 pi, 1. Cosine 0 is 1. And then cosine pi would be negative 1. Okay, so our points would be 0, e, and then pi over 2, and then 1 over e, right? And also pi and e, like this. Okay, so we have 3 points here. Okay, next one. So let's do part B. So 5 marks. I think the hardest part is the second part, not really the first part. Use the second derivative at each point you find in path A. Show that the curve has 2 local max and 1 local min. Okay, so we just take the f prime curve on the top. So I just copy the thing on top. Remember to like put back the thing that we cancel. Because like the thing, the reason why we can cancel it's because we let it as 0, but this time it's no longer 0 when we differentiate the second time. So here will be a product rule scenario, so do this carefully. So first of all, -2 is a multiplier, just leave it at the outside. The differentiate sign will be cosine. Differentiate inside will be 2. E cosine 2x. Copy the second part. And then plus, differentiate E is still E. And then differentiate inside is negative sine 2x. Differentiate inside of the inside is 2. And then copy the first part, sine 2x. Okay, so we got something like this. And at the same time, I'll just probably pull out a 2, pull out a E. So we have minus 4e cosine 2x. This will be equals to cosine 2x minus sine squared 2x. Okay, so we got this here. Just to make our life a little bit easier, we'll be substitute thing. So we can sub in things now. So let's put in 0. So f of f double prime 0. So plug in 0 and see what happens. So -4 is still -4. Cosine 2 times 0, so it's cosine 0. Cosine 0 is 1, so e power of 1. And then inside, cosine 0 would be 1 minus sine 0. So sine squared 0, no matter what, that will be 0 anyway. So since it's a show that question, so you need to write a little bit more. Since this is a smaller than 0, so means that it's opening downward. Therefore, max at x equals 0. Okay? And then you do the same thing for the rest of them. Pi over 2, I remember, right? Yeah, pi over 2. So plug it in and see what happens. So -4e. So cosine 2 times pi over 2. So cosine pi, right? Cosine pi will be -1 here. Cosine pi -1, so this is -1 again. Sine square of 2 times power 2, so which is just pi. So sine pi itself is 0, so squared is still 0. So this is still with this. So this is a larger than 0, therefore it's like this. So therefore min at x equals 2 power 2. And then third one would be same logic. Put pi this time, right? So put pi in, then we have -4e. So cosine 2 pi. So cosine 2 pi will be 1. Cosine 2 pi is 1, so this 1 again. So again, so cosine 2 pi is 0. So 0 squared is still 0. So this 0. So this is like -4e1. So this is smaller, not larger. So therefore, it's moving downwards. So max at x equals to pi. So we have 2 max and 1 min. So look at the question again. 2 max and 1 min. So I hope that we are correct here. At least it's inclined with their question requirement. So sketch a graph of y equals f for this domain 0 and pi, taking into consideration the relative values of the second derivative that you found in part B. So just try to draw out the probably just right here. So part C. So just draw the axis out. So this 0 and this pi. So we have a max, right? Max is 0. So, and do we have the coordinates of that? So 0 will be e. So this will be e. Okay. And then the next one would be at pi over 2. This will be the min, which is 1 over e. So which is a little bit smaller. It's still positive. And then at the end, you have back to the e. So we have these, sorry, a little bit ugly. So we have these particular value that we need to pass through. Oh no. So it's like this. Okay. Something that looks like this. So probably my scale is a bit ugly. So it should look something that looks like this. Okay. So kind of look like a cosine curve. And I think that's okay already. So if we really want, you can label everything. Pi over 2 and 1 over e. This is pi and e. And this is 0 and e. Yeah. So just make sure it's 2 max and 1 min. Okay. D. So let's see what happens. D. So we have a Maclaurin series here. So find a Maclaurin series for cosine. So I'll just look for a formal booklet. Give me a second. So according to formal booklet, remember you got the AAHL part for the Maclaurin series. So according to the AAHL formal booklet, the Maclaurin series for cosine, it's 1 minus x squared over 2 factorial plus x squared x power 4 over 4 factorial. Okay, and if they ask you, oh, please help me find the cosine 2x, then all you need to do, I think we just sub in x to be 2x. So cosine 2x. Just like composite function, whenever you see x, put in 2x. So 2 factorial is 2. 4 factorial is 4 times 3 times 2, so 12 times 2, 24. Okay. And then just clean up the number, so there's like 2x squared. This is like 16 over 24. So divide that by 8, so this is like 3, this is like 2, and x power 4. Okay, done. So I think this is kind of easy. Sorry, not x. So D1 is done. So let's see D2. So what happened in D2? Hence, find the Maclaurin series for cosine 2x minus 1. 2x minus 1. E to the power of 2x minus 1. Okay, we want to find this. So first of all, let's find what the hell is cosine 2x minus 1 first. So basically, you just go to your cosine here and then just minus 1. So it's like minus 2x squared plus 2x4 over 3. So what I've done here is just, so at the end, you put a minus 1. So the 1 here cancels out. Okay. So therefore, there's no more 1 in the right-hand side. So according to my formal booklet again, you need the definition for e. So e to the power of x. It's 1 plus x squared over 2 factorial. Okay, so it's following this particular pattern here. So e to the power of cosine 2x minus 1. Basically, you just go to your ex here, and then whenever you see x, replace the term in the right hand side inside. So you got 1 plus minus 2x squared plus 4 over 3 like this. And then plus, so it's x squared, right? So we square the thing on top. So it's kind of annoying, which I agree, but I think Maclaurin series should be probably one of the most straightforward topic because you're just using a formula. Okay, so we just group up numbers. So 1 minus 2x squared plus 2 over 3 x power 4. Okay, and then we just look at a question again. Up to where? Oh, including the x power 4. So x power 5, x power 6, they're all gone, no more. Okay, so x power 4 is our end goal. So all of these are the three terms here are within x power 4, which is okay. And then here, you don't need to expand everything, because if you expand everything, you know that this will create x power 4. The middle term will give you x power 6. And then the final term gives you x power 8. So these are actually useless because the question requirement just wants you to have x power 4. So what you need to do is just selectively expand the first one. Okay, selectively expand the first one. So 2x, negative 2x squared, which is just 4 x power 4 over 2. Right? Just like this. So, and then the rest, just leave there. You don't need to expand it. It's none of their business. So 1 minus 2x like this. And then here we just make them as a single fraction because they are the same like terms. So there's like 4 plus 12 over 6. So 1 minus 2x squared plus 16 over 6. So divide that by 2, 16 over 6, which is 8 over 3. Okay, so I think that's done already. Okay, nice. Okay, next one. Hence, write down the Maclaurin series for fx, up and then including the x fourth term. So hence, and the word write down, so it should be a easy one. So fx is e to the power of cosine 2x. So ask yourself, how do you go from part 2 to the question above? So look at here carefully. So if you remember the indices law, if I want to get rid of the -1 here, I just multiply I e the power of 1 inside, such that this creates the quotient itself. Like this, right? Because they will cancel it out. So therefore, I'll just, I don't think I have any space, so I just add one more in the back. It doesn't matter. So we have cosine of this, so I just copy it back. So e to the power of 2, cosine 2x minus 1. We just multiply this by e, okay? So multiply e to the left and right, then we have e times that. E times 1 minus 2x square plus 8 over 3 x power 4 dot dot dot, okay? And then just multiply it in, then you got this here. Okay, so that's why this is just a hence question. Okay, so we have e inside. And then finally, use the first two non-zero terms of the Maclaurin series, show that this particular approximate is correct. So 0 to 1 out of 10. So first two, right? Oh, okay. So we just integrate the first two terms. So integrate these two, okay? These two guys here. So e minus 2ex like this, 0 and 1/10, right? I remember. So let's try to integrate this. So this is just a normal power rule. So 2ex power 3 over 3. And then 1 out of 10. And 0. So put it in, then we have e over 10 minus 2e over, so we plug in 1/10 x cubed, so 1,000. 1 over 1,000 times 3, so 3,000 here. Okay, and then we make them same denominator, so we have 300e minus 2e over 3,000. So what I've done here is just multiply this by 300 and multiply this by 300. Okay, not 3,000, sorry. Like this, okay? And then this will create, I think, 298e over 3,000. And then divide top and bottom by 2. So we have 1,500. 149, I think. Well, I think we have the answer, right? So just make sure. Oh yeah, correct. So that's how we prove this part. So if this is correct, then I think majority of the thing on top should be correct. Okay, so this is the Maclaurin series question. I think it's kind of, I think probably this, for some students might think a little bit hard to think, but I think the rest should be okay. Okay, done. Okay, final one will be what we call a complex number, right? So first one is a 4-marker. So find a binomial expansion of cosine theta plus I sine theta power 5. So first of all, just remember Pascal triangle for the 5th power. 1, 5, 5. Sorry, 1, 10, 1, 5, 10, 10, 5, 1. Okay, almost done this wrong. So expand everything out, give your answer in terms of a plus bi. So let's try to expand this one by one. So first one will be just this one, power 5. So I just write it here. So cosine power 5, and there's no sign there. Next one will be cosine power 4 with 1 power of the second term, and with 5 as well. And then the next one is 10, right? So let's put 10 here. Cosine power of 3 theta, and that will the second part square. So I square is -1, so I just move this to be -1, and then sine square theta. Okay, and then the next one will be 10, so -10 cosine square theta I sine 3 theta. So it's like taking the second part here, multiply another I sine theta here. Okay, and then the final one, final two, I think, so would be 5 cosine theta. I times I is negative, negative become positive, so here's positive, sine squared theta. And then the final one, I believe it will be just plus, sorry, this should be 4, my bad. Okay, so like this, and then the last one I think will be I sine power of 5, like this. Okay. I think we have like things to double check later, so I think it will be okay. So now we just need to group all of the real part and imaginary part. So I just label them first. Real, 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 and then the imaginary part will be this one, and also this one. Okay, so just group them together. So the real part will be cosine. The real part will be cosine power 5 theta minus 10 cosine power 3 theta sine squared theta, and then plus 5 cosine theta sine power 4 theta. So, and then the I part would be 5 cosine power 4 theta sine this minus 10 cosine square theta sine 3 theta plus sine 5 here theta. So I think everything here should be okay. So I'll just assume I'm correct for now because I think we have part B to show it. By using the Morse theorem in part A, show that sine 5 theta equals that. So if we don't use binomial and then we just use the Morse theorem to solve this will just be cosine 5 theta plus I sine 5 theta. Okay, so and then they want us to show that sine 5 theta equals to the thing equals to that. So basically, so sine 5 theta, right? You need to observe that it's in the imaginary part. So we just compare imaginary part, IM. Okay, so sine 5 theta will be on the left. And then in theory, they should be the same. So 5 cosine power 4 sine theta minus 10 cosine theta sine 3 theta plus sine 5 theta here. Okay, so we got this here. Now let's look at the question again. We want to write everything in terms of sine. So we have some cosines here. So just need to remember that cosine squared theta actually equals to 1 minus sine square. At the same time, we got cosine power 4, right? So we just square both sides here. So 1 minus sine square, okay? And then expand this out. It's the same as 1 minus 2 sine square this, and then plus sine power 4. Okay, so we just sub in everything here into the thing on top. Okay, this is just the identity that we're using here. So 5 times we have a lot to do. So 1 minus 2 sine square theta plus sine 4 theta times sine minus 10 times 1 minus sine square theta times sine power 3 plus sine power 5 here. Okay, so we're doing one by one. Let's see. So the first part, 5. So remember we have a sine here. Okay, 5 sine times the 1, you got 5 sine. And then next one will be negative 10 sine. So sine squared times sine will be sine cube. And then the last one will be plus 5 sine power 5. Okay. Next one would be, again, be careful with sign. The sign is in here and this. So we combine them and multiply in minus 10 sine cube theta. Here will be plus, because minus 10 sine power 5. Plus sine power 5. Okay, so here we know whether we are right or wrong because they gave you the answer. So let's do the sine power 5 first. So we have 1, 2, and 3. So 5 plus 10 plus 1, I think that's 16, right? And then we do the cube. So we have minus 10 and minus 10. So these two. So minus 20. Final one would be 5 sine. I think that's the only one that's remained, right? So moment of truth and see whether we got this. So 16 minus 20 and 5. Okay, it's exactly the same. So I think we're correct here. Okay, part B is done. So up until this point, if you're able to do majority of the question with these two, I think level 7 would be achievable already, assuming the I is not too bad. So C1, let's see what happened here. Hence, show that pi theta equals to pi over 5 and 3 pi over 5 is a solution of this. So I'll just observe the differences here. So we can see this and that. It's like exactly the same, but with one sign removed. So I think we just write this. So since this equals to sine 5 theta, right? What we can do is divide both sides by sine theta, such that you will remove 1 over sine the right hand side, as mentioned in the question. Okay, sorry, this should be 2. Like this. And just solve this to be 0. Yeah. So show that pi over 5 and 3 pi over 5 is the answer. So we just use this one to show. Okay, so we plug in sine, we put in theta equals to pi over 5. So we have sine 5 times pi over 5 with sine pi over sine pi over 5. So as long as the bottom is not 0, this is obviously not 0. This will be 0 at the end. Okay, and then we plug in theta equals to, is it 3 pi over 5? Remember, yeah, 3 pi over 5. Then we have sine 3 pi over sine 3 pi over 5. This legit equals 0. Again, the bottom cannot be 0 because it's not a multiplier of pi. So therefore, pi over 5 and 3 pi over 5 are the solution. Okay, finally, let's do the level sum question for paper 1. Hence, show that sine pi over 5 times that equals to this. Okay, so when I look at this, right, I'm like, I'm kind of intrigued why they will write it in terms of this, to be honest. So the top is 1, 3, 5. The bottom is now 0, 2, 4. If you've done enough practices, this actually comes down to a quadratic scenario, if you look at this carefully. So, and we know that power 5 and this are the solution. And you know that this is an AAHL exclusive topic. So whenever you see the word solution, hopefully, like the roots comes to your mind. Okay, roots comes to your mind. So it's like sum of roots and product roots. Okay, so either one of them. And when I look at this, right, multiplying, I think this is what we call a product of roots question. So instead of writing sine first, we just let u to be sine square. Okay, so let u to be sine square. So making it a little bit more appealing to look at. Okay, so instead of writing that, we write 16 u square and then minus 20 u plus 5 equals to 0. So we'll just, so since this is my rationale, let's try to test it. So roots, right? So we just consider the product roots. Okay, so product roots would be, let's say, root 1 and root 2. Okay, let's say we call it like this. So root 1 and root 2 would be root 1 times root 2. Product roots of quadratic is this one divided by this one. So 5 out of 16. Okay. And then I'll always look at the answer itself. So the answer is like root 5 over 4. And then I got 5 over 16. So I would hypothesize I need to somehow square root this. Okay. So root 1 and root 2. We know the solution already. The solution is pi over 5 and 3 pi over 5. So actually, we know that root 1 would be simply just sine pi over 5, and root 2 would be sine 3 pi over 5. So we just substitute that in, and we have this particular thing. So since it's a solution already, let me think. Sine, oh sorry, my bad. So we let u to be sine square here, so therefore this should be square as well, because we need to follow the format of the original assumption of the let part. So we have this. So it equals to 5 over 16. And then we just square root both sides. So we've got root 5 over 4. I think that's okay already. So again, you might ask, oh, why shouldn't we negative it? Because we know that this is in the first quadrant. This is also in the quadrant of sine. So ASTC diagram, okay, ASTC. So this is pi over 5. Probably there's like 3 pi over 5, something like this. So both of them are positive. So therefore, this is just a positive number. Okay. I think that's basically it for this question. So I'm able to prove it. So I hopefully the marker will give me full marks if I do it this way. So any regards about this paper, I think this one is pretty easy. It's my SL video. For the Maclaurin, I think part A and B are more challenging because more algebra involved. Part D is just like depending on how good are you using like the Maclaurin series formula, and just be careful that of the fraction manipulation here. And then they are good enough that they gave you a question to check answer. So I think it's all good. And then the last part, I think these two are pretty trivial. I actually gave a lot of these type of questions before, so if you've done the old syllabus in math, I think this is pretty frequently tested. And then I think C1, like no matter, let's say if you can't do part A and B, you can still do C1, so don't skip C1. I think C1 will be 2 marks. And then part 2 might be a little bit more challenging because you need to actually look for keywords in the question. So you need to first understand it's 2 solution for some reason. The 2 solution in part 1 somehow goes to part 2. And whenever you do a solution, so there are 2 ways, right? Either it's like discriminant or it's roots. But since this is a AAHL question, so I think roots will be a more feasible choice because at the end you see 2 things multiplied together. So the first thing that you need to think, oh, it's just product root. So if you recognize it's a product roots question, then try to change this into a quadratic, which is a little bit more appealing. And then compute that product roots, and then you should find out that it's 5 out of 16. And then look at the answer, you're pretty close already. You need to think of the way to square root that. So you might think of like, how do I square root this, right? If you look at this let part, you've let u to be sine square. So therefore, your roots will be in terms of sine square. So and then you plug it back in and then square root that. And remember, reject the negative part because both of them are in the sine quadrant. But I would say that probably part 2 is a little bit more challenging. 11 here, I think it's just make sure you don't have any careless mistakes. And the whole paper, I think this is pretty easy. Number 9, the last question of section A, pretty easy. Number 8, be careful because I think it's a little bit more challenging for this one. And then the rest, I think, is pretty straightforward. Okay, so this will be my suggested answer for AAHL paper 1. So 2 hours, I think majority, if you know all the everything, I think you can finish this around like 1 hour and 15 minutes. Okay, so thank you for watching. So see you next time. Bye bye.